Hello, this is a screencast to demonstrate features of the Sahana Eden Climate Data Lab. This is a web application intended to be an entrant to the World Bank Apps for Climate competition, and it uses climate data from the World Bank's Climate Data Knowledge Portal. The Sahana Eden Climate Data Lab is a publicly accessible web application aimed at a broad range of users in the field of climate science. It's only just recently been built on top of Sahana Eden, which is itself a disaster management platform. We are intending to deploy this module for disaster risk reduction. The Climate Data Lab is designed to allow exploration and moreover analysis of climate data. Let's look at the user interface. At the left here we have some panels that control the map overlay and query results being displayed. On the right hand side we have a map view with a toolbar at the top and various controls for navigation and filtering. At the bottom of the map view is a legend, which is also an editable query box. So let's just look at the left hand side again. We have some control over the layers. So we've got a base layer, which is OpenStreetMap, and overlays layer. So we can toggle the map overlay if necessary, and all of these panels are collapsible, so I can just put those out of the way there. Then next panel we have select data. Select data covers the use case of a user wishing to simply explore the data. So you'll see that as soon as the Climate Data Lab is displayed, it's already showing some data. This allows users to start exploring immediately. Data is shown as colours by country on the map overlay. This color key at the top left allows interpretation of those colors. The scale on the color key is set initially from the range of the data, but it can also be adjusted by clicking the input boxes and changing the minimum and maximum values. Shall we do? So let's just change that value there to 200. So this is showing millimeters of rainfall anomaly, and if we change that there, the map colors will be adjusted. Incidentally, if we change that down so that some of the points lie outside of our range, if I change that clearer 30 millimeters, you'll see that some of the places on the map are no longer showing. This is a useful way to remove outlier values. So just put that back there. Now so let's select a different data set here. We select, go down to BCM scenario A2, select average there. You see that the from year and to year has been updated from the dates for that available for the data. We show that on the map. So now what we have is that's the simple way to select a dataset and show it on the map. Very simple. You select your parameters here and then click show on map. And of course, if we hover over a country there, we can see exact values and other information like the ISO code and the longitude, latitude, and the name of the country there. So the second use case we cover is comparison of data. This might be, for example, used by somebody who wishes to compare two projections to make some analysis of which one might be more correct in their case. So let's just go ahead and do that. If we compare the BCM 2.0 scenario A2 with B1 there, and we select the same statistic, average, and same years, compare that on the map. Then what you'll see here is that the color key has been updated with a delta value because it understands the units of the data, and when we do a subtraction it knows that it should show delta millimeter values. So this helps scientists to validate their data, and you can see that between these two projected models nowhere varies more than 10 millimeters on average. So that's how to compare two data sets on the map. Now another thing we can use this to do is we can filter the values. If you look at the top right hand side here, there's a filter box. Let's zoom to that. Filter box there. Now what we can do, for example, is we can say let's have a look at only at Northern Hemisphere countries. So latitude greater than 0, filter the map overlay, and this cuts out the Southern Hemisphere. Bye bye guys. And so this is useful when we are selecting parts of the map, or if we only want to concentrate on one part of the map. If we delete that and then click filter map overlay again, it unfilters it. Now, two useful buttons in the toolbar here: pan map, just allows us to easily navigate. Deselect that, and we have select places. Now select places, let's select the Caribbean. And then what we can do, you'll see here there's a button which has become active, show chart for selected places. Click that, we get a pop-up window and we see a nice chart for those places. And we can rescale it at will, and it will be redrawn. This is all done on the server and cached on the server. This is intended to be a clear presentation quality graph for use, say, in a report or on a website. Now, aside from resizing the chart, we can also edit the labels. So you see here that we have a single line on the chart. There's not very much data, but that's okay. And so what we do here, we will see which time series have been added to the chart, and we can simply edit that. Let's cut that out. The idea of this is that we can provide a more useful label. If I type in my more useful label and then click reload chart, then we'll see here my more useful label is now the label for that line. Perhaps Caribbean would be better label there. Caribbean, not very good at spelling. Okay, so what we have is a single line, and of course that's not very useful. It would be more interesting if we get more places. So let's have southern part of Africa added there. Just select that. Again, select show chart for those places, and we have two lines. And you'll also notice that these lines have trend lines added, and the trend lines have the error information, intercepts and gradients added onto the label. So that's how it covers the charting. Now, next thing we can do is we can download a printable map image. This takes time because it's generated on the server. So whilst that's generating, I'd like to just talk about some background for this website. We had sat down and talked with climatologists from the BCCI in Norway, also ADPC in Thailand. There's a beautiful map screenshot there popped up. Okay, so we had talked with the ADPC in Thailand, and we also took part in a couple of feedback workshops with climatologists working for the government in Nepal. We collected user stories so that we could target this broad range of specific, quite technical in some cases, specific needs for these users. And what we realized was that whilst there were various great web applications available for exploring and visualizing climate data, there aren't really that many that allow much data analysis beyond the simple visual comparison. So the needs of these users who really need to make important decisions aren't being met. So in light of that work, we developed this, and I think this is really our killer feature. And what this is that, well, basically everything that the system is doing is communicated with the server via an expression language, and you can see this in the if we just look at that legend there, we can see that's actually an expression, mathematical expression there. And what this allows, if I just click that, we can edit this. So that's a comparison there. And what if I wanted to add them together, for example? We can do that. And what if I wanted to say, well, let's say if I was let's say I was a hydrologist and I wanted to inform policymakers about predicted changes in rainfall patterns using projections. And but in our region, in the region I was working, then the A2 and the B1 scenarios were weighted, say in a 60-40 ratio. And what we can do, we can just change this to, so we hit A2 multiplied by 0.6. Whoops, reloads. That's annoying. Oh well, here's one I prepared earlier. So my Safari does that, but okay. So what I was saying was that okay, so we can, for example, we can put in an expression where we have weighted two projections. So one of the projections, A2 is multiplied by 0.4 and B1 by 0.6. So we can weight projections, combine them, and we can compute that and show that on the map, which is great. That's really useful. And so that's a very simple user interface for doing so. Now, this expression language is very simple. It uses very basic arithmetic, so you got plus, minus, multiply, divide. You can raise things to integral powers, and you can use statistical functions. Minimum, maximum, average, standard deviation, which is very useful for calculating error bounds for data, which scientists requested a lot at the workshops, and sum and count. So these are, with this simple language and these simple functions, we can pretty much perform any kind of sophisticated, well, not super sophisticated, but any most reasonable statistical calculations that the users can dream up without having to have lots of confusing graphical user interface. Excuse me. So that's why it's really called a climate data lab, because what it does, it goes beyond visualization and exploration, and it allows for serious scientific analysis of the data, all via a web interface, and it allows charts, and it allows printable maps. So this is designed to be really useful in the field. When we realised that, for example, graphical user interfaces tend to make things easier, we also realised that they tend to limit the flexibility, which is why we didn't bother with too much graphical user interface, and this simple expression language feature allows complex analyses, and that's really the killer feature of this web application. So just like to say, this runs on Amazon AWS. It's a very scalable application. This is all open source software. We believe in open source, and of course we believe in open data for a better future. We think it's a very great move for the World Bank to open up their data. So thanks for watching this screencast about the Sahana Eden Climate Data Lab. We really hope that you can make good use of this web application using data from the World Bank.